Good morning, ladies and gentlemen, and welcome to our panel discussion on managing wetlands for climate change, adaptation, and groundwater sustainability. I'm Yulia Vistana, Senior Water Program Officer at the International Atomic Energy Agency. And today we will discuss what is the connection between wetlands and sustainable development goals. How wetlands buffer in extreme events, what's their impact, what's their role in climate change. But before to start the discussion and to introduce our panelists, please let me to open the floor for our Deputy Director General, Head of the Department of Technical Cooperation at International Atomic Energy Agency, Mr. Liu.
Thank you. It's my great pleasure to participate in this side event. Ladies and gentlemen, IAEA leveraged the power of science and technology to address the effect of climate change. Our researchers are working on cutting-edge nuclear science and technology to help countries adapt climate change in multiple areas, including food production system, water resources, marine ecosystem, urban and industry infrastructure, and effective early warning system. Through our technical cooperation program, the IEA also help build capacities of the national level to monitor and adapt climate change using nuclear applications. Wetlands are crucial components of ecosystem, serving as a nature buffer against the extreme weather event and providing essential ecosystem service. They absorb carbon and help to prevent flooding. Climate change, however, is causing wetlands to disappear, which threaten the vital functions. Today, we will discuss the indispensable role of the isotope hydrology in unraveling the complex relationship between the wetland, groundwater, and climate change. The IEA uses isotope hydrology, a powerful nuclear technique, to track water's movement and origin. By tracing source and pathway, we gain invaluable information and insight into the dynamic of this ecosystem. Accurate and precise data on water resources obtained through the isotope hydrology can contribute significantly to the sustainable management and the provision of wetland. For example, the Ramsar site, Estero del Barra wetland area in Argentina is one of the largest freshwater systems on the South American continent, extending across almost 40,000 square kilometers. The IEA has been working to preserve the site, reach biodiversity, and support the local Guarani communities through an hydraulical characterization of source, age, and the interaction of the various surface and groundwater components using nuclear technique. The IEA has mapped the water resources to help improve water balance estimated and support the development management policies toward preserving this wetland. So this is one of the good examples we can share. And finally, I would like to say thank you for your commitment to preserve wetland, and I look forward to the enriched discussion and the collaboration that will undoubtedly emerge from today's session. I thank you very much.
Thank you very much for opening remarks. And now, please let me to present our distinguished panelists today. Today with us, we have His Excellency, Mr. Joan Francisco Fassetti, representative of the permanent mission of UN Organization of Paraguay, and can I tell what you're former Minister of the Environment of Paraguay? Thank you. And also, next panelist, Mohsin Hafiz. He is Director of Water, Food and Ecosystem in International Water Management Institute. Also, welcome Flore Lafayette de Michaud. She is a doctor and she is Senior Advisor for Europe at the Convention for Wetlands in Ramsar. Also with us we have Mr. Kenzo Hiroki. He is professor at National Graduate Institute of Policy Studies, coordinator, and the high-level expert and group and leaders on panel on water and disasters. So opening our discussion, we will have also, I would like to mention that we'll have also special guest. He will come a little bit later for closing remarks, Mr. Johannes Kuhlmann, UN Water Vice Chair. So let's start our discussion about wetlands. And I would like to ask the first, Mr. Mohsin, been working in the international water management. How do you see the wetlands within the complex management challenging the regions and globally?
Thank you very much, Julia, for inviting me. It's an honor to be here as a panel. When we are looking around the disasters, around the 90% of national disasters are relevant to the climate extreme. That's about the floods, drought, and heat wave. That's very common. And when we are talking about the in Asia Pacific, they are in Asia, particularly the climate extreme, and many reports are highlighting that the frequency of the disasters are increasing over a period of time. On the climate change is adding those more uncertain about the disaster, and then it's a bit more uncertainty about how to deal with those disasters. So wetlands are typically providing that one the services in several ways. Is a national protection, is the first strategic defense against that kind of climate extreme, whether we are talking about the flood or we are talking about the droughts, and it's also supplementing that when the groundwater recharge into the certain areas. So again, that the ecosystem services in that context, I will give one example of the Colombo wetland, where we are actively working it. It's a Colombo in the city which is built it around the wetlands in Sri Lanka, and there is around 220 square kilometer area. Around 20 square kilometer is a wetlands, and those wetlands are basically also helping us in terms of that one the flood protection, as well as saving the GDP around 1%, and also contributing to the flora and fauna and then the healthy ecosystem there. But over a period of time, of course, that the things are happening, that the landfills are happening, and then the wetland area is reducing, and everything is there. So when we're talking about the IME's experience on a global on a wetlands, and then how the wetlands are acting, it's a context specific where we are talking about the wetland. If we are talking about the wetland, then it's not in the middle part of that one of the catchment. It will store the water, it will reduce the flood and frequency, and it will also be water would be more available. The typical example is in case of Colombo wetland, it's storing around the 40% of the flood water. But if the wetlands are located at the headwater, that's where the problems are more. It will be storing the water, but then it will increasing the flood frequency downstream and that one. So it's important on that one. When we are talking about the wetland, it depends on the hydrological catchment of that area. If that's a kind of what's the soil moisture conditions there, how much water could be stored, and if the soil is already saturated, then the flood water will exceed, and all sort of things are happening. In the particularly when we are talking about the wetlands, it's also, and the other part is on the flood, on the drought mitigation. Again, in the dry season, in the flood season, the wet season, you will store that water, and then in dry season, you could use those activities and everything. And wetland could also serve it as a kind of other benefits like the ecotourism, as well as on the different transport modality is a part of the larger wetland, and as well as on that the people, the agriculture systems, the people are using that water for growing vegetables and the foods and everything is there. So if it, in summary, when we are talking about the role of wetland, it depends on where that's located, and it's a location specific, but then it depends on a lot more on the type of that one, and somewhere it will attenuate the floods, but it will improve that one. In other headwater wetlands, it will be generating more floods, and that will be increasing downstream the floods. Again, the nature-based solutions, another angle which we can look around that one, the wetland, the nature-based solution along with the infrastructure, the hardware infrastructure, how that could be blended together to improve that one, the wetland, the ecosystem services there, and as well as on more balancing of that one. So again, the wetlands are really providing that one the buffer to deal with the climate change, and that's one of the natural defense there. So therefore, we need. But overall, the globally the wetlands are decreasing, and there is a scientific evidence of saying that we need to work together on to deal with the climate change, especially on adaptation and mitigation. Wetland could play a critical role. Thank you.
Thank you very much. It's excellent overview of the wetlands and how they have positively impact on hydrological cycle. Also, you mentioned that we need to collect more data about the
Yep.
wetlands and the hydrology. When I was a child, in all of my fairy tales, we had something strange in wetlands. So, something bad was happening there. Something was stolen. And then we started to dry out all wetlands in the region. No one cares so much,
Yep.
unfortunately, about that, because from the childhood I was trained that wetlands is related to something negative. But only now we can see how they play important role here and how important to preserve and then collect. So this is really very strong message on the impact of wetland to help us to mitigate and to adapt to climate change and also to deal with these disasters, as you mentioned, about the floods and droughts. And now I would like to ask His Excellency Mr. Fassetti. Mr. Fassetti, what is about Paraguay? Please tell us about more how the data collection help you in Paraguay to manage the wetlands and to improve this resilience of your ecosystems.
Thank you very much for this invitation, and also I commend the agency and for organizing this side event. Yes, I would like to mention before that in my country, for many years, we worked in wetlands, in natural wetlands, not in built or constructed wetlands. And the last, I would say, 20 years, a strong emphasis was done in promoting for instance, irrigation for rice production, which is absolutely important, and not only for production, for food in this case, but also for nature conservancy. We have Paraguay is a country that has one of the largest availability of water per capita, fresh water per capita in the world, but also is a connection, is in the migration path of very important bird life. So we have to consider two realities. One is the natural wetlands we are sharing the Pantanal with Argentina, with Bolivia and Brazil, and part of the Pantanal extend along alluvial river, which is the Paraguay River, and connects to the Paraná River. And so I'm talking about an extension of 3,400 kilometers long. And it's a system of wetlands. So we have very important wetlands there. Why is important for us conserving the Pantanal, conserving the wetlands? Paraguay is a landlocked country. So we have no shores on the sea, but we have larger rivers, and we need to conserve this river. We need to avoid, for instance, to reduce the cost of dredging the river every year. And one of the important services provided by these wetlands are avoiding sedimentation. This is one, but also other services are extremely important and are related to climate change. So climate change can affect not only, through altering the hydrological cycle, but also the rise of temperature can alter the biogeochemistry. of wetlands. And also, as it was mentioned by DDG Liu and also by the director of the institute, it can alter the services. So instead of providing services, we'll create this service. So on the contrary, so if one of the service is sink of carbon, and if this biogeochemistry is altered, instead of sinking or capturing carbon, it will release. So this is a big impact for climate change. So to study the biogeochemistry, and of course we need to study physicochemical parameters, but also we need some specialized techniques as the using hydrology isotopic studies, and using carbon-14, using nitrogen also, and different isotope, natural as well as radioactive isotopes, because to study the comprehensively the the biogeochemistry cycle, we need all these tools in order to also to, based on building this baseline, data baseline, we can create regulations, we can create laws, and regulations are and laws are part of policies or strategies. But not only at the national level. I mentioned that within these 3,400 kilometers, we have four countries. We have Brazil, Bolivia, Paraguay, and Argentina. So we need to harmonize our methodologies to analyze what is happening in these wetlands in order to have the same language, in order to have to be able to compare the results obtained by laboratories. So this is why it's so important having capacities at the national level, but also having a platform, I would say, at the regional level in order to discuss all these results, in order to create also regional policies. We cannot implement an environmental policy, a national environmental policy, without taking in consideration what our neighbors are doing in the vicinity. So this is why we need to work not only looking at the national level, but also at the regional level. Thank you.
Thank you very much. Thank you for highlighting us importance of wetlands in biogeochemical cycle, in hydrological cycle, but also in transboundary comparison. So actually wetlands can connect us also. And here I would like a little bit to tell more about isotope hydrology role for water balance, because now we are developing the technique to understand how wetlands are supplied by groundwater using the radon isotopes. So in this case, we can precise water balance. You also mentioned water balance is highly important. It's also important for transboundary comparison. We should understand how different counterparts, how different participants in transboundary comparison share the storage on wetlands. So here it's our role, and we are using isotopes in our isotope hydrology section to understand and to precise, but also to quantify the amount of water was stored under the wetlands, and the amount of water was depend on groundwater supply of the wetlands, because this is complex ecosystem. And to continue discussion about complexity of the wetlands ecosystem and role of groundwater, I would like to ask Dr. Flore. She is representative of Ramsar, and she is one who can give us more information about knowledge gaps in terms of wetlands and groundwater interaction, and how there's tools of the convention to advance water management of wetlands.
Thank you, Julia. So very pleased to be here in this discussion that highlights the complexity of wetlands, groundwater interactions and climate change, especially as negotiators are now in the final stage of discussions on global stocktake and global goal for adaptation. And I think it's very important to have this discussion here. So thanks for the invitation. Let me first maybe introduce the Convention on Wetlands to the audience here and maybe also to the online audience. So the convention is the oldest multilateral environmental agreement. It was signed in 1971 in the Ramsar city of Iran. And it now counts 172 parties to the convention. And its aim is to see the conservation and the wise use of all wetlands through local, national, and international actions. And it's a convention that hosts an international network of wetlands of international importance, or Ramsar sites, and we heard Pantanal, and we heard also other examples earlier by the speakers. And this network counts more than 2,500 wetlands, and that represents 150 million hectares. So it's quite a large network. And so to answer to your question on the question of integrity of wetlands and groundwater, I would like to really recall that the integrity of wetlands is strongly dependent on sustainable water management. And this is true whether climate change or not. This has always been true. And in that regard, if we dive into these groundwater-wetlands interactions, of course, this is extremely complex because parties have to face not only water management at the hydrological catchment level, but also at the aquifer level. And aquifer level is in the invisible part, so it's even more difficult to mobilize people around it. And I think these difficulties also are connected to knowledge gaps. And here I'm coming to your question. In fact, in 2010, the convention issued a report, a guidelines to manage groundwater, and it looked quite straightforward. It was a stepwise process to identify the water transfer mechanisms, what to choose as a period to report, and how to also use modeling, etc. But in fact, in the reality, this knowledge requires time, funds, and capacity to be produced. And this is a key challenge for parties, to find these time and funds and capacities to develop this knowledge. And especially, we must also consider that knowledge, even if it's present, it's not then all is solved, because then there is the management part and the governance part that comes into the picture. And as well, His Excellency mentioned the difficulty to have governance at a transboundary scale, and this happens a lot. We have several transboundary Ramsar sites, and there are, of course, several transboundary groundwater aquifers. This becomes even more difficult for parties to cope with that knowledge projection and then that use of the knowledge, that wise use of this knowledge. So what I can tell also is that, of course, in the climate change, and that was mentioned by my colleague, the uncertainty makes it even more difficult. The uncertainty and the unpredictability and the difficulty to compare current situations with past ones, because data trends are no more reliable. So where can we help in the convention? So I would say in three ways. First, through guidance, technical guidance, but also community of practices. And there is a recent resolution that was adopted at the last COP, COP14 in Geneva, that set up a mechanism to have a community of practice on climate resilience through ecosystem-based approaches and nature-based solutions. So this is one aspect. A second is encouraging and fostering the international cooperation, as His Excellency mentioned, through two ways. One is the transboundary Ramsar sites, where parties formally agree to collectively manage a site. I mean, to agree on the management of the site. And second is the Ramsar regional initiatives. There are about 15 of them as of now, and they cover or a region or a thematic. For example, on the Mediterranean, on the Nordic Sea, or even in other places of the world. And third, I think the convention can encourage a political process to really put to really recognize the value of wetlands. And this is something that is, thanks to the convention, is increasing. And I think there was a mention of national strategies for wetlands, national wetland inventories. These are moves that are going on. And I want to mention, maybe for conclusion, the Freshwater Challenge, a ministerial roundtable this afternoon at 4 p.m. That will be a commitment from several parties to restore rivers and wetlands up to 350 million hectares of wetlands and 300,000 kilometers of rivers that will be connected to the NDCs. And this is a very interesting move, I think, and I invite all to join that event this afternoon. Thank you.
Thank you very much. Thank you, Dr. Flora. Flora, you told us very important things. You told us how we need to fill the gap using from science to management to policy. So here we see what we are good decision can be done only based on the reliable data, on the scientific, innovative approach. So we can actually improve the management here. And also thank you for highlighting conventions. For me, personally, this convention, Ramsar, was always some kind of magic convention because it's really dealing with ecosystem in a very interdisciplinary, integrative way. Thank you so much for that. And would like to ask now, Professor Hiroki, you're a specialist on disasters, but also on climate change. What climate change pose, what kind of threats climate change pose on wetlands? Maybe from in Japan or in regional scale. Thank you.
Thank you very much. Actually, climate change is happening now. You know, in Japan, in elsewhere, in here. So what to do? That is the main question we have to ask by ourselves. Then, like in the case of Japan, 40 years back, we had a certain level of the heavy rains. After 10 years, the frequency of the heavy rains increased by 10%. After 20 years, 40%. Means that we are having more and more heavy rains. This is not only the case of Japan, it's happening in the United States, it's happening in Germany, Europe. So, how to solve it. Then the main problem was that we could not estimate how much of the increase of the flood event, considering the speed of the climate change. Now, compared with the 20 years back, we are now fairly accurate calculate the amount of heavy rains, how much of the peak rainfall is increased because of the climate change impact. In the case of Japan, for the Class A rivers, 109 Class A rivers, the Japanese government concluded that 10% of the increase of the rainfall, which comes to the 20% increase of the flood peak. And this 20% implies a huge investment we have to do, probably $1 trillion of US dollars or more, if we are to prevent it by embankment and the new reservoirs and dams. So the conclusion of the Japanese government is that we have to rely more on the watersheds rather than structures. So then comes the importance of the wetlands, the small or large. The wetlands can serve as the new buffer zone to prevent flooding. We have the good example since even before the 70, 80 years back, the capital of Tokyo is saved from the wetlands in the upper stream. That stores a huge amount of water when the flood comes. So we know that wetlands helps us to prevent flood. But then comes the question whether we just keep the wetlands as it is or what to do. If we just conserve or keep it as it is, we cannot prevent future floods. So what we have to do is to combine, integrate gray and green infrastructures. That is what we need. My group, high-level experts and leaders panel on water and disasters, are now creating the new principles on integrating green and gray infrastructures. By doing that, we have to more fairly accurately estimate the impact and also benefit and value of the wetland. That comes to the more of the investment to conserve wetland. Then comes the question of the how those wetlands is valued. It's not only for the prevention of the flooding, but it's also for the creation of the new water sources. Then comes the new technology, making use of the isotope, because we by integrating green and gray infrastructure, we are having more water sources coming into the groundwater. And then new water cycle is created, hydrological cycle. Then the behavior of the water will be changed. Then we have to know what what's happening. That comes the isotope technology. Then we can make use of the water resource more efficiently and also at the same time prevent flooding. That is what the Japanese government is intending for. Thank you.
Thank you very much. So we can see here the role of technology, how it's important, because before I didn't know what constructed wetlands can be used also for flood prevention. Normally they're constructed to prevent to clean waters from different type, from mostly it's waters from houses. So we are constructing this constructed wetlands as nature-based solutions, but it was really, for me, it's the first message what I got, what it can be constructed now to prevent and to deal with the disaster risk. And also, we are creating additional hydrological cycle, what is also important for us to understand how it's functioning inside of the whole ecosystem now. Thank you very much for highlighting all these important technology roles here, and also a green and gray infrastructure role. Here we are coming to the end of our session, and I would like to ask each of panelists to tell one message important. What is the next for our wetlands? What's the next for our wetlands at the global scale, at regional and local scale? So, someone would like to start? Or we can.
From my point of view, conserving wetlands, conserving what we have now, but also trying to expand, to create more constructed wetlands. As for food production, we need to secure food for the humanity. In the case of Paraguay, we are a country of 6.5 million people, but we produce food for 80 million people. And we use a lot water. 97% of our exports are absolutely related directly to water. So for us, wetlands are extremely important. So it's conserving and also expanding the surface. And as it was mentioned, of course, study the relationship between wetlands and aquifers. We have a very, I mentioned the Pantanal as a wetland, but also we have the aquifer Pantanal, which is below the wetland Pantanal. This is just one example. We have many other wetlands that are connected, are connected to our aquifer system. So conserving and expanding.
Thank you.
Protecting their wetland is very important, but not only in terms of quantity, but also the quality. Make sure that it's healthy and then that could serve the various needs. And one of the important thing is we are looking at system level approach, the hydrological cycle. And hydrological cycle is important that to do the fill in the data gaps, and for saying about the surface water, about the groundwater, and how that's connecting at a system level, whether we are talking about global or whether we are talking about transboundary wetlands or the regional wetlands or the local wetland. And that's where the remote sensing, the artificial intelligence, the data mining techniques, plus as well as the hydrological model coupled could provide a breakthrough, and then we could have a much more monitored way of that one, how to make sure that when the wetlands are healthy and it's protecting us against the disasters, and then serving as the ecosystem for the communities, and also serving the food production, which is very vital, as Honorable Minister Sahab mentioned. Thank you.
Thank you. Thank you. Florence?
Thank you. I would say that a multi-level action is required. So at the national level, for instance, there should be policies, national strategies that support the production of knowledge, because this requires funds and it has to have a sustained efforts. But at the same time, there should be platforms and support at really local level where site management are embedded to support this platform of local governance to have every stakeholders on board. Thank you.
Thank you. Mr. Hiroki.
We have to create a policy in which the wetlands are positioned as a tools to preserve and to help us develop sustainably our society. Then to do that, we have to convince our government and even private sector that this policy is very valid. But the government likes to calculate in monetary terms. How much is it? And how much do we get benefit? So we have to have a more, making use of the technology like isotope, the reveal in monetary terms, the multiple functions of the wetlands, in terms of the flood prevention, in terms of recharge to the groundwater, in terms of the vegetation varieties, and those have to be turned into understandable, manner. Then, if we, we could convince those politicians and decision makers, then we have to put each of the wetlands, small or large, into our new policies. It's not just a conservation. We have to proactively make use of the wetlands. Then, the government agrees to do more investment to conserve wetlands, and then to even enhance the usage of the wetlands so that the entire society and the people benefit from it. That is what we need now.
Thank you very much. So today we did a very intensive discussion. Actually, this short period of more than a little bit half an hour, we discussed a lot of complex things in what relate to the wetlands and climate change. Particularly, we discuss how science is important. So we also should be open for different innovation and to look to different perspectives here. We also should consider technology, because we have natural wetlands, but also we have constructed wetlands. And with constructed wetlands, they can be used not only for as treatment facilities, because we are not normally using it before for treatment facilities, but they open us some opportunity to adapt to climate change disasters related to climate change, for example, droughts or floods. And they're creating inside of hydrological cycle additional hydrological cycle what we need to better understand, particularly because they also can change in groundwater flows, the groundwater storage here. And our sophisticated knowledge and collection of the data important for decision makers, because we can manage only something what we know. If we don't know something precisely, we cannot manage it in a good way. And this management and decision makers give us to the policy level. So I would like to thank all distinguished panelists, because we are running, and maybe we have one question. Do we have time for one question? Maybe someone would like to comment from the auditory or give a question.
We are developing. I am part of this group of research. Despite I am ambassador, I am still doing research with the university. We have a consortium of universities from Bolivia, Argentina, my country, Paraguay, or my university, but also the Musée National d'Histoire Naturelle de Paris. And we are doing, we are studying a very important wetland in between Argentina and Paraguay, which is irrigated by a very important river, Pilcomayo River. And this is a river from the Andes, and is affected a lot by sedimentation. The first study done on sedimentation using techniques, isotopic techniques, was in 1982. And the first mission of the agency came to my country in 1982 to start doing this research. We found through these studies the reasons why this river was disappearing. So this very important wetland was going to be also was going to disappear. So we start doing all these infrastructure works in order to assure the irrigation of this wetland. And now what we are doing is because there is a complaint. We were talking the last few days, we were talking about the society, the community participated in the conservation of water resources. Now we are studying the effect of the disappearance of one commercial fish species because they are not able to migrate to Bolivia through this river. And our theory in my group is that fishes are using this wetland, and through this wetland they can arrive to Bolivia. So, but this is something that we are studying now using strontium 86, the rate strontium 86, 87, and we will probably have the result in 2 more years. But this is very complex situation because this is affecting economy. This is affecting also other SDGs. So it's very complex, and it's very useful to use isotopic techniques. Not only radioactive, but also stable isotopes.
Thank you very much. So I feel our gap about the community also involvement. We always should think about the community around, because I remember we had, like in my region, we had problem with community. When we would like to construct wetlands, they will come and tell us, what are you doing here? We don't need any more wetlands. So that is why also community can be negative and positive in this way. And also probably we need to work more with different social groups like children to change their attitude to wetlands if they've been educated through negative view on wetlands, with schools, with parents, with indigenous community, with locals. And after we will have stronger impact on the in our management systems, because we have also strong community understanding what is going with wetlands and how they can be involved in the protection of the wetlands. Thank you for sharing all your excellent case study. It was absolutely interesting discussion. I hope our audience also learned a lot. Thank you for who've been with us here and who've been online. Thank you very much.